Hello, my name is Artem Rechkin. I'm first year master student of Moscow State University Physics Department. Today I'd like to tell you about article which I have recently read. Its title is Dependence of Langmuir probe data on distance from the axis of a collisionless plasma. The main idea of this study, the change in the current voltage characteristics of the probe as it moves from the reactor to the walls. Here is the structure of my talk. First of all, I will start with the concept of Langmuir probe. Secondly, I'll tell about the basic of the method and the meaning of the current voltage characteristics. And finally, I'll make a conclusion. So, what is Langmuir probe? The Langmuir probe is a device used to diagnose plasma. An electric probe is a small metal electrode which is introduced into the investigated part of plasma. The measurements consist in registering the probe current depending on the value of applied voltage. The volt ampere characteristic allows us to determine the local parameters of the plasma. The most simple electrical cassette for probe measurements in a DC discharge includes a measuring probe, a reference electrode that close the probe cassette, and adjust the source of probe gas voltage, and measuring instruments such as microamperemeter and a voltmeter. The measured probe potential difference is the sum of V and Vs on the graph, where V the potential of the probe relative to the undisturbed plasma in its vicinity, and Vs is the potential difference between the plasma and the reference electrode. And the electric current at the probe is the sum of the oppositely directed currents of electrons and positive ions. If you create a plasma negative with respect to the plasma on the probe, that is V is less than 0, then the electrons will be repelled from the probe, and their current will drop. This happens because the number of electrons that have sufficient velocity to overcome the field of the probe decreases. With the further increase of probe voltage, the probe repels practically all electrons and attract ions. The current to the probe become purely ionic, and we pass into region of the ionic saturation current, that is third region in picture in the graph. The volt-ampere characteristic of the probe is non-linear, as we can see. I would like to say that with the help of the described diagnostics, one can find such local plasma parameters as ion current, electron temperature, or plasma potential and plasma density. So the Langmuir probe is an integral part of any plasma physics laboratory.